Hey everybody, it's Truce. So today I wanted to give a quick intro to LLM agents. And so what we're going to do is build a simple financial market data chatbot that talks to the OpenBB platform. And so here I gave it a question, give me a basic profile for Broadcom, and I got this stuff back. And so there's really, I guess, three things we'll go over. We'll do a quick intro to the OpenBB platform, which is a fantastic and very cost-effective way to use market data. And then we'll talk about the basic LLM agent workflow and some more complex agent workflows. And hopefully you'll get away with a roadmap to make a chat agent that will talk to pretty much any API, such as any REST API. So let's get started. So how did we get all this great information about Broadcom? The answer is the OpenBB platform. So this is the OpenBB homepage. OpenBB has a few different things. There's the terminal, which is a market data workstation terminal. There is Excel integration. There's some AI, which is the Copilot, and what we'll be using, which is the platform. And so the platform gives a one-stop shop API to a whole bunch of market data providers. And so we have pricing with EOD we have fundamental data with AlphaVantage and FinHub and financial modeling prep and Polygon, and these also have real-time market data. We have Fred for economic data. We have the news API for news. So it's a one-stop shop API for any market data that you can subscribe to or that's available for free anywhere on the internet. So let's just try the OpenBB platform, do the 2-minute kind of walkthrough to see how it works. So this is a Jupyter notebook with a Python script. And so we import some stuff. This is really the stuff that matters for OpenBB. And so we get this OBB module. It has some utilities and these different categories of market data. It's a modular system, so these are the extensions that are loaded. They can get updated individually, and these are some market data providers we have configured. And so we can log in with our username and password, and there we go, we're logged in. And we can do some account housekeeping and update our credentials for the services that we might have subscriptions to. And let's just do an equity search. And so here we're searching for Merck, and the provider is SEC, so it's searching the SEC Edgar service, and it comes back with the symbol, which is MRK. And here we can do a real-time price quote, and we can use the Python magic to kind of see what's available. So if we have equity, we can, if like under P, let's just do it again. So once we hit the dot, we see there's all these different functions that are available under equity. So if we go to price, then there's historical pricing, there's national best bid and offer, there's historical performance, there's quote. So we just did the quote, don't need to do it again. And so let's just see what's in this object that we got back that we saw before. And so we see there's some metadata. So like the provider here is FMP, which was the default. We just gave it a symbol. So, and then there's some other stuff in the results field has the actual quote that came back. And so if we look at the results, then that's always a list. And it's a list of, in this case, FMP equity quote data. So depending on what you asked for, it might be like if the provider was something else, it might be Polygon equity quote data or something. So if you asked for historical data, you'd have a list of like dates and prices and or something. So basically you always get a list back, and it's a list of OBB objects, and it'll depend on what you requested. And so if you look at this object that came back, we can do some things to it. So one thing is a chart. So this is a single quote. It's not going to make too much sense to make a chart. But if we ask for historical data, We could run a chart with a lot of fancy options and technical indicators. Here we can turn this into a dict. It's already a dict. And then we're represented as JSON. And so up here we have like the JSON string of what got returned. And just to take one final look, let's do 2. So we can convert it to a data frame. We can convert it to LLM is going to be an LLM string representation, which is typically JSON. We can convert it to NumPy or polars. So the bottom line is we always get the same structure back, which is like an object that has a results field, which is a list of return values. And so whichever service you call, you're always going to get that same structure. So just like it gives a single API to 100 or almost 100 different market data services, they always come back consistently in the same way. So it basically abstracts a lot of the complexity and the differences between the services. And the last thing I want to show is that for free, as part of this, we get this REST API. And so what we can do is, if you have clients that are out there in your firm and maybe they don't run Python, you can hit this REST endpoint and get all these same things are exposed. So that's the 2-minute overview of the OpenBB platform, and it's it's a fantastic platform. It abstracts a lot of the complexity of dealing with a lot of different market data services. So now what we're going to do is build an agent, an LLM agent, to answer questions using the OpenBB platform. So what is an LLM agent? Anytime you're using the LLM to manage the control flow of your application, you have an LLM agent. Anytime the LLM is used to make a decision about what the next step to take is, or to perform an action on your behalf, like querying the OpenBB platform, that's an LLM agent. So it's really using the LLM as kind of a programming language to run a process. And so you give it a prompt that says, okay, go through this process step by step, and then based on what the user enters and like the outcome of queries to OpenBB, like then do like some other stuff. And so it can be kind of magical that it works as well as it does, some of the time at least. And I'll put some links in the description about a couple blog posts about how agents work. And so, what our specific LLM agent does is it lets the user ask a question about financial markets, and then it checks, like, is there an OpenBB tool that can answer this question? And then we run the tool. And then based on what comes back, maybe we can give the answer, or maybe we need to run another tool after that. And so we can run multiple tools in sequence and eventually answer the question. So if we give the LLM a text description of the tools, and then we ask it to pick the best tool to answer a question, that's something that LLMs and ChatGPT is really good at, and it has a deep semantic understanding of text, so it understands the question and it understands the description of the tools, and so it will pretty reliably pick the correct tool if there is one. Okay, so we just talked about how LLM agents work in general. So at this point, we should just look at our agent and walk through how it works specifically. So our agent works as a Streamlit application. Streamlit is a Python module that makes it really easy to put a web interface on any kind of Python functionality. And so what does it do here? Like, it loads a bunch of tools. So like, what are these tools? Well, one thing that OpenBB does, which is pretty useful, is when you have this REST API that OpenBB provides, it provides this OpenAPI.json, which is the spec for the API. So for each endpoint, this JSON file will have some information about the description of the function and the parameters and et cetera. So I kind of leveraged that, and I said, okay, what are all the equity functions? Some of these are useful, some of these are a little more obscure, and some of them I don't have a good API that I subscribe to. So I ended up with about 15 or so functions. And then so for each one, I wanted to simplify the calling convention so that ChatGPT could handle it somewhat better or more easily. So I created my own YAML file. And then so, for each function, I would I would just put the metadata in sort of a simple format. So here's like equity price quote. I'll have a description. I'll have a path to the OpenBB object. I'll have a schema for the arguments. I'll have an example. In some cases, I'll specify the provider. And then what I do is for each one, like I create a function. So here I have like a function factory. It reads the YAML and it creates a function that will call OpenBB, using that specification in the YAML. And then I use LangChain. LangChain is a module which gives access to ChatGPT functionality and simplifies a lot of the the things that you want to do with ChatGPT. And in particular, it'll give you a structured tool. And so structured tool, I can just give it this function that I just generated, and the name and the description and the argument schema, and then it'll create a tool that I can then just call that tool, and it'll do all the right things to tell ChatGPT how to use the tool. Okay, so we have a bunch of tools. So we want a system prompt that explains how to use the tools. So this is our system prompt. And so it says, okay, you're a stock market assistant. This is your objective. You're given a number of tools, and then you have some instructions like to follow this specific process. And like first, make sure that this is a question about a company or a stock ticker. And if it is, then extract the symbol. If there's no symbol in a company, look up the symbol. And then based on the symbol, retrieve the information and then compose a response. And then here's an example. And then in the code, like I'll actually append some stuff to the end of this saying, here's a description of each tool, like in plain English, and here's how you call the tool, and here's what comes back. And then in addition, ChatGPT has function calling functionality built in a structured fashion. So you also append some JSON saying, okay, these are the tools that are available, and these are the calling conventions in a structured JSON format. So it's a bit of a belt and suspenders method. I'm explaining what to do in the prompt, and then there's also a structured format that ChatGPT uses. Okay, let's try it. So let's go to our Streamlit application. And let's say, what is the ticker for Southwest Airlines? And it comes back with this answer. Let's see how it did it. And okay, so just queried that directly, and it got this answer. So it can basically, it took that query and it said, I need you to run this function. The function is get equity search symbol, and the calling signature is query Southwest Airlines. So then client side, we run that signature. We go back to ChatGPT and say, it resulted in this JSON object, which I'm giving to you. And then based on that, ChatGPT comes back with a final answer and says, this is the ticker for Southwest Airlines. Let's try something a little bit harder. Let's say, what is the last price for, I'm going to misspell it, Delta Airlines. And let's watch what it does. So, okay, so it searches this, and it actually fixes the spelling on the fly. So what we see here is like the actual name in the database is Delta space airspace lines. So that still doesn't work even after it fixed the spelling, which I told it to do in the system prompt, to correct obvious spelling errors. And so it says search, get the search, and here it broadens the search, and it says I'm going to search for Delta, and this time it comes back with the correct answer, which is DAL. So you can see a couple things. One is it can do a multi-step process. Number two, it can follow specific instructions like correcting obvious misspellings or common misspellings. And then, you can make it retry, until it sort of, gets to an answer. So it's able to follow kind of a logic, like first find the symbol and then find the quote. And it's able to kind of like make these adjustments and retry things if they don't work. Okay, so to speed things up a little bit, I just queued up a whole bunch of questions. And so I said, what's the weather in Las Vegas? And it says, I'm sorry, I can only provide information related to stocks. And for current weather, you can check weather.com. So that's a good answer. Here I made up a company. It said I couldn't find any information. Could you please check the name or provide more details? So I asked for a company profile, kind of like what we saw like earlier, and we get all this information. I asked for historical split information for Apple, and so it gave me this list of splits going back to 1987. I said, what are the total assets for Merck? And it's 106 billion. What was the most recent cash flow from? So the last one was assets, and so that's from the balance sheet. So this will be from the cash flow statement, and comes back with the answer. These also give a link to the 10K filing. What was the most recent net income for ExxonMobil? So that's from the income statement, and so we get this answer. We ask for a PE ratio for Salesforce CRM. Then we ask for a price to sales ratio. And then we ask for revenue per share. And we ask for the latest dividend data. And so we get the last 2 dividends. And we ask for a specific date. So this function, I believe, for dividends gives a whole list of historical dividends. So we can ask for a specific historical date, and we get an answer. What was the performance for Eli Lilly from 1 year ago? And it's up 89%. And which ETF has the highest weight in Merck? So this is an interesting question, because what happens is the function that we give it returns all the ETFs that contain Merck. And so what happens is it gets that huge string and it says, okay, what's the highest weight? And this is a good answer, but it's not the actual highest one. So you do have to remember with some of these quantitative, like logical questions, that ChatGPT is a little bit like an intern, and sometimes it's extremely smart, and sometimes it sort of doesn't pay attention, and it does things sort of in a half-assed way, and it kind of BS's a little bit. And this is one of those times. So what you kind of have to do is, if you have a question like this, which ETF has the highest weight in Merck, you sometimes want to write a function that will say, okay, given this symbol, go and get the answer, and then turn it into a data frame, and then find the maximum value in the data frame and return that. And so, this is a situation where you have to be a little bit careful, and it didn't actually give the right answer. But anyway, I hope you're convinced that if we write a good function that will return something useful based on the ticker, if we write and we give it a good description, this system will go and find the right tool to call, and then give the answer to a pretty broad range of questions. So I wanted to talk about a couple of sort of more advanced things to maybe think about when you're thinking about building agents. Like, one is that this Streamlit application is quite simple. It's it's here. It's like 113 lines of code. And so this is a fairly easy way to stand up a chat interface. But a lot of people just connect these things to Slack or Discord or something. And, then you can have like a Slack channel where people have some tools and they can ask some questions. So that's another way that people go about it. The other thing I wanted to mention that's pretty wild is, LangChain can actually create an agent, based on a JSON spec. So, if you have this is a very complicated spec. And so what I did is I loaded it into the JSON and saved it as YAML. And then, I did some stuff. And then there's a LangChain thing here where you can say, make an agent based on the YAML. And, surprisingly, it did start to do some useful stuff. And so, the thing about this OpenBB API is it's extremely complex. So it has 203 endpoints. I think the limit on the number of tools might be 128 for ChatGPT right now. I mean, don't quote me on that, and it might change. But that's a lot of, that's a big prompt if you have to explain 203 endpoints and, tell it how to choose some things. So, but if you have a simple API, a simple REST API in your firm, and you just want to create an agent on the fly, you might be able to create it pretty quickly using LangChain and this tool. And you might want to simplify it and take away some complexity and only expose a subset of the parameters. And you might want to look at the descriptions, make sure the descriptions are extremely clear. But for simple REST APIs, you can probably stand up chat agents pretty quickly. Okay, so one more thing I wanted to mention is LangGraph. So one thing that I did not do is expose the news API. What kind of happens is if you say, give me all the news for Merck, then you get, a bunch of like market roundups where Merck is mentioned somewhere with 25 stocks. So you kind of want to narrow down the prompt and say, only return things which are primarily about Merck. Maybe you want to read individual stories and summarize them and do different things. So like the existing functionality is super simple. It's just it'll generally follow a decision tree. It'll say, okay, what's a tool I can use? Call it. If I'm still not there, maybe call another tool. And so it'll be, just a few levels in a decision tree. And you don't want to give ChatGPT a gigantic prompt where you're kind of explaining some algorithm to go and figure something out. And if it's news, then do this, and if it's a quote, then do that. So LangGraph is a kind of solution for that, where you can, instead of having a decision tree, you can make a finite state machine and say, okay, start in this state, and then like do some stuff, maybe follow a decision tree, and then if you succeed, then you're in this new state, and then if it's news, do this. If it's not news, like do that. And so it sort of makes it tractable to have more complex workflows that are still reasonably likely to get a predictable answer. So that's something to think about. The other thing I wanted to mention pretty quickly, because it's kind of crazy cool, is there's a flow that is used by tools like Agent GPT, and let's call this thing Agent GPT and say, find the best coffee grinder for espresso beans under $500. And so like a thing that you might do, or what is say, okay, can I answer this as ChatGPT? Do I know what the best espresso grinder is under $500? Probably not. But then you can ask, well, what would be the steps that you might want to follow, to answer this question? And it might divide it into 5 steps or something, and say, okay, go and search Google for all the coffee grinders under $500, and then triage the ones that are good for espresso, and then go and find reviews on Wirecutter and Amazon from consumers, and summarize it and output your recommendation. And so like that's another very complex workflow where you can say, here's an objective, and then if you can answer it, give the answer. If not, break it down, put the steps into a priority queue, and then just iterate. Pop the most important, the next step off the queue. If you can answer it, answer it. If not, break it down and put those steps in the queue, and just keep iterating until there's no additional steps, or until you can answer the question. And so this is a pretty cool thing. I'm not sure that it's always going to work like really well. It's kind of an enterprise tool, but it's another very interesting thing that's out there, and I just wanted to mention it. So what we did here today with LLM agents is we use the LLM and prompts and tools to answer a question using a complex sequence of steps. And essentially, we use the prompts and the tools to run a program. We programmed the LLM. We used it as a more general programming language or general purpose computer. And so if Alan Turing were alive today, he might write a paper that says prompts and tools are all you need, or if statements and go-tos are all you need. If you have that, if you have if statements and you can loop and you don't run out of memory, you can do anything that you can do with any computer. And so a question that arises, what's sort of the limitations of that? Like, what are the types of questions and if statements that the LLM can reliably decide? And, so one thing we've seen is if you give the LLM a good set of descriptions of some tools, and someone asks a question, it can reliably decide, which tool to use. Okay, so one of the things that AI is good at, so AI has, this incredible facility with text. So one thing we can do is we can ask it to write a limerick, and let's just write them. So we'll write a limerick on LLM agents where the first letter of each verse spells out agent. A language model quite smart. Okay, I'm not going to read the whole thing, but you get the picture. This is, a very smart human, could probably not come up with something as good as fast. It knows like a ton of facts. Like if you go to Wiki Roulette, this is a site that just generates like a random Wikipedia page. And so let's see. Oh, I'm going to ask it like when was this listed in the National Register of Historic Places? So let's try that. And, obviously that's an extremely random fact. And you can do this on any page and you're probably going to get the right answer. So, basically the LLM trains on a trillion or a few trillion tokens. And, it absorbs those tokens, it kind of digests them into like a form where it can look things up and carry on conversations about them. And, when it does this, it's going to learn like a tremendous number of facts. And so it's pretty good with language. It's pretty good with well-grounded facts, like especially if you ask it something very specific and you prompt it well. And if you maybe give it some text to answer the question based on, it's going to do very well with all these text questions. What it's not good at is logical questions. So this has been a controversy that, if you ask it what countries in Africa start with the letter K, or just what countries in the world start with the letter V, it's going to give the wrong answer like a lot of the time. It's gotten better. Like some of these questions, it used to not be able to like count to 1,000, and then it used to not be able to tell me if I say, Sebastian, who is Sebastian's son's daughter's grandfather, it would say, who the hell is Sebastian? So when, logically you can say that like Sebastian is the grandfather, so the name is Sebastian. So, this is a simple math question, like, is this number a prime number? And it answers correctly now, but it writes a program to answer the question. By definition, if you multiply two numbers, it cannot be a prime number. So it's not good at this kind of at logic. It's very good at text. It's a poet. It's not a quant. It's a word cell. It's not a shape rotator. It doesn't have a sort of mathematical models in its head. And this is a very good paper by a group and that did a randomized control trial at BCG. And so they said, okay, we're going to divide the consultants into two groups and give one group access to ChatGPT and one no access. And what we see is, and then have them write a case study and then say, show them a case study and ask them, to provide a recommendation and a discussion. And so, and then you can grade them and you can, measure the quality. And so you see this big quality improvement from the people who used AI. And then one group got training and one group did not. One thing that you really see is there's this group here off on the left. And so it's interesting, the red group got additional training, and so some people managed to screw up, and the reason is I'm pretty sure is they were overconfident, and ChatGPT gave some hallucination or something really dumb, and they put it in their case. So what this means, like Centaurs and Cyborgs on the jagged frontier, there are things that AI is rapidly improving at, and it's really, really good at. And there's some things which may be quite similar that just need a little bit of logic and where it's really going to screw up really badly. And so you have to kind of know where you are on the jagged frontier if you want to use it effectively. And so, the things that will work well with agents are, things that are simple text problems with very simple logic. It's not going to do like complicated logic. And the centaurs and cyborgs mean you really do well with AI when you combine forces, and when you use the AI for what the AI is good at, and when you write tools that are good at things that can help the AI, and when the human is involved in the task and you're using the AI as a co-pilot to improve your work, and you're not kind of relying 100% on the AI to do stuff. Okay, that pretty much wraps it up. So we covered, quite a bit of ground. We built this bot. We looked at the OpenBB framework, and OpenBB is a tremendous module. It allows you to access a whole different bunch of market data APIs in a very consistent way and get information back in a very consistent way. So of course you can use the APIs independently. It's just somewhat more work that way. And then we talked about like the agent workflow and how agents work, and I'll put some links in the description. Then we went through some of the code, the concepts for our particular agent, and I'll put some links to the GitHub and all the code also in the description. And then we talked a little bit about some advanced agent workflows and some other things you might do beyond this like really simple workflow. So if you lasted this long, if you listened to the whole thing, I appreciate you very much. I'm not the best presenter in the world, and that's part of the reason I'm doing it, to get a little bit better and hopefully to share some useful information. If you have any question, just put it in the comments and I'll try to answer. And talk to you soon. Bye.